Okay, so we're going to prove that for n greater than or equal to 1, n choose r is less than n choose r plus 1, if and only if 0 is less than or equal to r, which is less than n minus 1 over 2. Okay, so let's start the proof. So we can see this is an if and only if proof, but we can just go step by step. We don't have to do P implies Q and Q implies P for this particular proof, and I'll show you why. So let's go ahead and start with assuming n choose r is less than n choose r plus 1, and where by the construction of the choose function, I know 0 is less than or equal to r, which is strictly less than r plus 1, which is less than or equal to n. Okay? Just by the structure. Okay. So, this is true if and only if, right? So we're just going to rewrite this as n factorial over r factorial, n minus r factorial, less than n factorial over r plus 1 factorial, and it'll be n minus r plus 1 factorial. Okay, so what I'm going to do next is, since everything is positive, right, n and r and all that is positive, I know this sign won't change if I multiply both sides by, n or r, right? So I'm actually going to multiply both sides of this inequality by the multiplicative inverse of the left-hand side. So of course, if you multiply it by the multiplicative inverse, this gives you 1 is less than, so it's going to be n factorial over r plus 1 factorial. And then we can rewrite this as n minus r minus 1 factorial. And since we multiply both sides of the inequality by the multiplicative inverse of the left-hand side, right, I have to do it on both sides. So this is going to be r factorial, n minus r factorial over n factorial. Okay, so now I can reduce this. So this is going to be 1 is less than n factorial over n factorial. That turns to 1. And then I'll go ahead and rewrite this. So r factorial times n minus r. And I can rewrite n minus r factorial as n minus r times n minus r minus 1 factorial over, and then I'm going to want to rewrite r plus 1 factorial as r factorial times r plus 1. And then I have the n minus r minus 1 factorial. And now I know r factorial over r factorial is 1, and n minus r minus 1 factorial over n minus r minus 1 factorial is 1. So I am left with 1 is less than n minus r over r plus 1. And in this instance, if I multiply both sides by r plus 1, I get r plus 1 is less than n minus r. And then, of course, I can add r to both sides to get 2r plus 1 is less than n. And then I can do subtract 1 from both sides. 2r is less than n minus 1. And then I can divide both sides by 2, right, to get r is less than n minus 1 over 2, which is exactly what I wanted to show, right? And by definition, I know r is greater than or equal to 0. So, thus, we have r, or I guess 0 is less than or equal to r, which is less than n minus 1 over 2, right? So we're able to get from here, right, all the way to here, which is what we wanted to do for the proof.